everyone, it's Terry Bruce, and this is another 10-minute nonprofit evaluation tips. Now, this month we're talking about data analysis. We have talked in the past about sort of the evaluation ecosystem idea. We've talked about evaluation at a high level. We've talked about distribution and utilization of data to drive decisions. Now we're going to spend a lot of time down here in this teal bubble talking about what to do with the data that you have. And we're going to spend this month's videos on some hands-on exercises of getting into some very basic analysis, but there's actually a lot you can do with just a couple of very basic sort of, and I'm loath to use this word, but statistical analysis. That makes it sound much more complicated and sort of highfalutin than it is. There's some very basic things that you can do to start making meaning. So I asked you guys to collate up some data during the month of August, grab a data set that has at least 5 values in it, and to get 3 different such data sets. So this could be number of people served, number of people who came to your center or some of your events, could be your number of members or donors or volunteers, volunteer hours given, case management services provided to clients, dollars raised, number of members or donors who renewed their membership or donation, whatever it is. And I asked you to try to get some variety so that you're working with a variety of data like currency as well as like hours versus people, so that you can kind of get some different experience playing with different types of numbers and see how they sort of react. So if you have done that, you should have a nice little spreadsheet that looks maybe a little something like this, that has 3 different tabs, that has your 3 data sets. Now, if you also followed my instructions, it should be a nice, neat data set. Hopefully there's no blank rows, there's no kind of blank columns, and all your data is kind of consolidated tightly together, which makes life much easier. Now, the first sort of, again, statistical analysis, but I'm sort of putting air quotes around that. But the first sort of basic thing that you might want to look at when you have data is a total, right? So this little sample data set that I'll be using to show examples on throughout the month is computer classes that this fake nonprofit is teaching. So this non-existent nonprofit, this is made up data, is teaching some computer classes. And these are the instructors who are teaching each class. These are the dates the classes were held on. Let's assume that these are like one-time 2-hour or 4-hour classes, and the number of people who registered for each class. Now, already we can see that there's a question about this data set, right? Because this is number of attendees. So which is it? Is it the number of people who attended or the number of people who registered? So that's the first thing, is you need to be really clear about your data and what you're tracking. Now, a lot of people, when I'm working with them around like helping with reporting and evaluation, one of the first requests I always get is, help me pull all of my data into a spreadsheet, and then I'm just going to analyze that data in 100 different ways to see if it's telling me anything important. And what I always say to them is, no. I love you, but no. And we've talked about this in the past and in past months, right? That your data is not a magic 8-ball that you can just sort of shake and say, please tell me something interesting. You need to start with a distinct research question that you are asking the data to answer. So that's the first thing too, is, well, do I want to know how many people attended or how many people registered? Do I want to know the no-show rate for my classes? Do I want to know the completion rate? What percentage of people who started the class completed? And that's a different data point, right? The number who registered, then the number who showed up to at least one class versus the number who completed. So I would need a bunch of additional data to answer those different questions. And this is why you need to start with that research question, is you need to know if you're collecting the right data to answer your questions. We can see that there's a wide variation in attendance or registrations for these classes. We can see the date, but we don't know the day of the week and time of day these classes were held. Now, we can probably get the day of the week just from the date, but we'd have to go back and look at our schedule to figure out what time these classes were held. Is the day of the week or time of day contributing to this wide variation in interest in these classes? We'd have to look at that, but we'd need additional data, the day of the week and the time of day, to see if that's a contributing factor. We can also see that the two lowest enrollments came from classes taught by Smith. Is it the teacher? And we see two, the highest was Jenkins, and Jenkins had a pretty good enrollment for this class. So is Smith an unpopular teacher? And maybe that's the problem. On the other hand, the two classes that had the lowest enrollment were Excel. Maybe there wasn't a lot of interest in Excel versus Word and PowerPoint. But we can also see that the two lowest enrollment classes were the same class. They were both beginner Excel. Every other class had only one class. You either showed up at the time it was being held, or you didn't get it that month. This could be maybe we hit capacity and then we had to add a second class, because if you look, there's actually 18 people who were interested in beginner Excel, which is second only to beginner Word. If you look at it by topic and level, this actually had a really great enrollment. 18 people total wanted beginner Excel, and enough to fill two classes or have us run two classes. So you can already see, depending on what we want to ask, we may not have enough data in this data set. We've got data that will tell us something. How many people took this computer class, right? Or at least how many people registered for the computer class. But by itself, this data still doesn't tell us a lot. So that's the first point, is just make sure you're collecting the right data to answer the questions you want to answer. So that's the first thing I want you to do right now, is pause this video and look at your 3 spreadsheets and figure out what is the question or questions you would want this data set to answer for you. And if you don't have enough information in the spreadsheet to answer those questions, that's a gap that you need to identify how you're going to fix it. How are you going to get that data and collect it on a routine basis going forward so that you always have the right data to answer the questions that you want to answer? All right, so now let's start doing some, again, air quotes, statistical analysis on this data. So the first thing we might want to do is get a sum total of the number of people who registered for our classes, right? And if you haven't used formulas in Excel or Google Sheets or Salesforce or Microsoft Access or any of those tools that you might be using to analyze your data, almost always writing formulas starts with typing an equal sign in a cell and then starting to type the name of the formula or function, and that will bring up a list. If you don't know what the syntax is for the formula name for what you're trying to do, usually somewhere there's a little FX or similar button or text that's hyperlink that you can click that will open a box that will give you a list of all of the functions, and you can actually search and find out what the syntax is. Most of these systems use similar syntax, but not always. Some of them always have like 1 or 2 functions that it uses its own little proprietary thing. So for instance, some systems will use an exclamation point to mean not equal to, and some will use, we used to call these munchie mouths in grade school, or alligators, but the less than and greater than sign back to back in this way will mean not equal to. So that's one distinction depending on which system you're using. So depending on what you're using versus what I'm using in this video, the syntax may not be exactly the same, and you may need to Google to find out how to word the same thing in whatever tool that you're using. Just a little disclaimer there. So to get a sum total, it's just equals sum, open parentheses, because the range of where the data that we want to apply the function to is always embedded in parentheses in formulas and functions. In this case, I want to total up the number of attendees/registrants. I can click and drag to select the range and then close parentheses. I could have done the same thing by typing if I know the range. So I'm actually just typing in this cell, but you'll see that the computer starts highlighting the range. So visually I can confirm it's got the right cells selected, and I get the same value either way. So you can either type the whole thing, or you can type part of it and select part of it, or any combination of what is most comfortable for you. I'm just going to type a little text here so we know that this is our sum total. So 64 people were served by our classes this month of June. Woohoo! So the question is that good? Is 64 a lot? We don't know. We don't know, right? There's no context now for this. We're like, okay, we served 64 people. Great. And this is where, you know, in previous months, we've talked about like outputs and how outputs are just volume. All they mean is volume of stuff done. We served 64 people. There is literally no context here for how many people we wanted to serve, how many people we could have served, our capacity for service. There's no context. 64 doesn't mean a whole lot without context. So as I talked about in this month's blog post, that difference between data and information, right? Information would be some context. Did we serve more people this month than we did last month? Did we meet our goal or serve as many people as we could have? We don't know without that those data points being on our spreadsheet for comparison as well. So that's the second thing I want you to look at on your data sets. Do you have enough data points to create context, to make a value judgment about whether your numbers are good or bad, if they meet expectation, exceed expectations, or below expectations? Because otherwise you're just like, yay, we served 64 people, but who cares? Why is that important? Does it mean anything? You won't know if you don't have that context. In this case, if our goal was to serve 50 people, well, woohoo, we achieved our goal. So we are like really excited. Yay. If our goal was to serve 1,000 people, well, now this is very sad because we didn't even come close. I'm not even sure 64 people is statistically significant in terms of meeting our goal. So it really makes a difference. And it also leads you to that knowledge and wisdom, which is, what are you going to do about it? If we only had capacity to serve 50 people and we served 64 people this month, that's actually a bad thing. We were over capacity, which probably impacted students' learning because they may have had to share computers, which means each person who had to share a computer got less computer time and less hands-on practicum time than the course was designed to administer. So they may not have learned as much as they could have if each person had had their own computer and had more solo time at the computer. In addition, with over-enrollment, the teacher now is spread more thinly because they're answering questions for more people and have to provide more one-on-one assistance. Maybe we overcame that capacity by giving them a teaching assistant to help, but if we weren't expecting to be serving more than 50 people, we may not have planned or resourced to hire a teacher's assistant. And so again, people weren't getting as much assistance as the course was designed to provide, and it may have led to lower outcomes. So this context really is super, super important. Now, additionally, another good number for you to have is an average. Oh, well, actually, before we get to the average, I do want to talk about one other thing here, a whole count versus a distinct count. So we served 64 people, but did we? Was it 64 unique people? People could only take one class and there were no double enrollments? Or did we maybe serve 30 people, right? So there's a difference. Like if Sally took both beginner Excel and beginner Word, she's one person who took 2 classes, or she's one person who had 2 services. And this is a very important distinction. So when we talk about counts, we have to mean a whole count, which is, you could think of it as butts and chairs or services provided, versus a distinct count is how many unique values that we had within that data set. So you may have one donor who donated 3 times, right? So there's still, it's not 3 donors, it's 3 donations and 1 donor. So also when you're doing sums and counts, make sure that you're being really clear about what you're counting. Both numbers are perfectly acceptable to use. We served 30 people and provided them 64 services, or 64 services were provided to 30 people this month. Our reach and touch was 30 people. Very unique people came in and got services. But the amount of time and effort and resourcing required was the amount equal to providing 64 services. So they're measuring different things and they're both valid. Sometimes you'll hear people say, oh, well, you're double counting if you're not doing distinct counts. Well, again, it depends on what we're counting. If it's services provided, your staff literally provided those services and those services took X number of hours. It doesn't matter if one person got all the services, those hours of service are still valid to count. But as long as you're clear, it wasn't 15 different people that you served, because that's talking about your reach, how many people you helped. It would be disingenuous to say, well, we helped 15 people if it's the same person getting all of the services. All right, the next statistical analyses that we might want to do is calculating an average. And again, the function name is just average. Actually, we're going to put the average here, and over here, we're going to put the formula. And again, we're just going to select the range or type the range, and there's our average. Now, I'm actually chronically surprised by the number of adults who do not know how to compute an average or even what the average means. I'm actually shocked how many groups of professional white-collar adults I've had to teach how to compute an average or what an average is. So I'm just going to mention that briefly in case you are one of those people who have not had to use this much in life. And last time you saw this was like basic math or algebra back in high school. So what the average does is it takes all of the values in any given data set and it totals them up. So the total is 64, and then it divides that by the number of values in the data set. So the total of number of people registered for our classes was 64, and we offered 5 classes. 1, 2, 3, 4, 5. So we would take 64 and we would divide it by the number of values, which is 5, and we get 13. So that's how the average is calculated. You total up all the values and divide by the number of values to get the average. And the average says basically, this is kind of where most of the values sort of landed around, right? It's not the middle point. That's a different statistical number. And it's not the most common number. That's a different statistical function. Those are median and mode. You may have heard those terms before. But the average is sort of where most of the values are sort of clustered around. So it's sort of the fulcrum point, if you want, of where the values fell within the distribution of the values in the data set. And you'll notice that none of the values are exactly the average, right? Some are below average, some are above average. That's kind of the whole point of the average, is the average is sort of somewhere in the middle of all of those. And we can see now that, you know, this class had 10 people. Our average is 13. Is 3 people less than the average statistically significant? We'd have to do another calculation to know that, but 3 people doesn't seem like a huge amount. 20 people is 7 above. 7 is quite a lot, especially since this whole class only had 8. 15 is only 2 bodies above the average, so probably not significant. This is only 2 bodies below the average, probably not significant. So we can see the average kind of tells us where most of these classes fell and in terms of enrollment, and we can start looking at outliers, really highs and really lows, and say, okay, why? What happened here? These are so far off the average that something either went really well or really poorly, and we can start trying to diagnose and figure out where we need to put our effort to correct these items. Now, here's something really important to understand about averages and computers, that there's a difference between blank or null or nothing and 0. 0 and null or empty are not the same to the computer. Now, I want you to take a look at the fact that we have 2 beginner Excel classes, right? And all these other classes only had 1 cohort. It would be just as accurate to add those 2 beginner Excel classes together and say we had 18 people receive beginner Excel instruction this month, right? That is a true statement. It's 18 people were enrolled in beginner Excel. 20 people were enrolled in Word, 15 in PowerPoint, and 11 in Advanced Word. So we leave this one blank because we've added these 8 to this 10, right? So now we have sum total from all these values that's the same, right? It's still 64 people were enrolled in our computer classes. What happens if we calculate the average, though, on this data set versus this data set? Are we going to get the same average? The values are all the same. The sum total is all the same. So what do you think? Are we going to get the same or not the same? All right, I'm hitting enter. It's different. It's different. Why is it different? The numbers didn't change. Terry, what is the computer doing? So remember, the average is the totals of all the values in the data set, the sum total, divided by the number of values. We have rearranged our data so that we now only have 4 values in the data set. So 64 divided by 4 is 16 versus 64 divided by 5 is 13. This is really super important to understand. Now there's additional. Watch what happens if I put a 0 in here. The value changed again. Why? Because 0 is a value as far as the computer is concerned. So now I'm back to dividing by 5 values. If I take out the 0 and leave this blank, I'm dividing by 4 values. I want you to look very carefully at your spreadsheets right now. And I want you to go through and very carefully look. If you've been putting zeros when you meant null or empty, you need to take those zeros out because they're going to affect your computer's math. It is not appropriate to put a 0 here. Why? Because this class, in this data set, this number 8 has already been accounted for in the 18. We would put a 0 here if we ran this separate class, but nobody enrolled. That would be 0 enrollments. But in this, because we've consolidated this beginner Excel class into this 18, this is now a null value. This is basically, I could delete this off the row because it's all been consolidated. So you need to understand that if you've been putting zeros when you meant null, like we didn't run a class this month, or these people weren't asked for a donation. So the fact that they didn't make a donation, it's not that we asked them, they gave us $0. It's we didn't ask them. There was no opportunity. We were closed for the month of June, so we didn't need any volunteers. So you wouldn't put 0. It's not that they could have contributed hours and they just didn't show up. It's that there literally was no opportunity. So in those instances where there's no opportunity or the numbers are accounted for in another row, you need to leave those blank in your spreadsheet. If you actually mean like they could have done something and they did nothing, like literally returned a big fat goose egg, then put zeros. So I want you to go through and clean up your spreadsheets and start removing zeros and get in the habit of leaving blanks where you literally mean null, or deleting those rows. If you're like, we are not running a second beginner Excel class at all this year, or we're not running any advanced Word classes this year, then just take them right out of the spreadsheet. Or you need to leave them blank. All right, so that is beginning of some statistical analysis and concepts that you can start looking at. So do your spreadsheets have all of the data values that are necessary for you to be able to answer the questions that you want to be able to answer from your data? Are you counting whole counts or distinct counts? If you need to count distinct counts, there's formulas and ways to do that, but you need to think about that. And is that important to you? And are you tracking the right thing of whole count versus distinct count? And is your spreadsheet set up to do that? Some totals and averages, and making sure your nulls are actually null and your zeros are zeros, and you mean 0 when you say 0, or do you mean null when you say 0? And if so, get those zeros out of there. So you may have some cleanup to do on your spreadsheets, and adding some data like goals and targets may be super important. And then starting to play with some of these basic formulas and your computations. Join me next week. We're going to go even deeper into this and continue with some of these examples of how to pull meaning out of your data. In the meantime, if you have any questions about anything that I've said or need help with your specific spreadsheets or data sets, you can post a comment, go back to the Substack and post a comment in the comments on the blog post, or you can email me at terrybruce@gmail.com. Thanks, everyone, and I'll see you next week.